Hello students, I hope you guys are doing well. Hope you are working hard on the homeworks. So this is lesson number 7.5, solve trigonometric equations. So we are going to continue with solving trigonometric equations, but here in this problems we are going to use double-ended formula and then factorize and then find the general solution. Okay, so let's move on. So problem number, this is problem number 4, as we've already completed problem number 1, 2, 3 in the class. So I want to make this video so that you can go check the concept to make sure your concepts are clear. Okay, so you have 1 minus 2 sine theta equals cosine 2. So at the most, what can we do? This is just a sine, it's not even sine square. This one is theta, this one is 2i's theta. So can we change this cosine to another, we can apply an identity that has with theta, and you can clearly see we can use double-angle formula for cosine theta. But cosine theta, even though we have it is cos square theta minus sine square theta and 1 minus 2 sine square theta and 2 cos square theta. So we have so many, and 1 minus 10 square theta over 1 plus. So the best option bet for us is the one that has the sine. And you can clearly see this one is the best bet for us. So in place of cosine 2 theta, let's replace it by 1 minus 2 sine square theta. So this stays the same. In place of this, I'm writing 1 minus 2 sine square theta. Okay, let's bring all the terms on one side, or we can still work, you can see there's a 1 here, there's a 1 here. So this one, we can cross it out by subtracting. So you subtract minus 1, so you get this minus 2 sine theta, and that side minus 2 sine square theta. We can still divide by minus 2 both sides, and you left with sine theta equals sine square theta. Then you subtract this sine square theta both sides. So subtracting sine square theta both sides. So this goes away, and you're left with sine theta minus sine square theta equals 0. Now here there are two sine thetas here. So one of the sine theta can be we apply undo distributive property. So this is times 1, and this is sine theta. So one of them can be pulled out. So I'm going to write down this is, you can write it as sine of theta. And then what stays is, the 1 stays minus, and one of the sine theta is already pulled out. So what is left is sine theta. This whole thing equals 0. Apply the zero product property, so either one of them, so here, so either sine of theta is 0, or what are the other option is this parenthesis is 0, 1 minus sine theta equals 0. And this you can still sort it out, and then you can add sine theta both sides, and you get it 1. Or you can write sine theta, this crosses out, and you get sine theta equals 1. So what you get right now is this will become sine theta is 0. Sine of what angle is 0? And you can see sine is 0. So sine for this angle, if the angle is 0, the terminal sine that's a 0. And also, if you see on the other side here, it is this is minus 1, 0. This is 1, 0, and cosine of 0. So this is sine of 0 is 0, and here this one is sine of this angle is pi. So sine of pi also is 0. So you have two answers for this. Either we have theta, so this theta takes the value 0 degrees, that's here, whenever it's 0 degree, sine 0 is 0, so that's why, and theta is, and the other one is pi here, clearly see? So that's pi. And then we can say, okay, now we can write a general equation for this. So it's not just 0. So the general equation is a general solution, not equation. General solution is theta equals 0 plus, and now so if you have 0 here, this is 0, then you can go back to 2 pi. So it's 0 plus 2 pi, 4 pi, 6 pi, 8 pi, like that. So we can just write it is 2 pi times 2 pi times k, where k is an integer. So there you go, you're done. That's the general form. But and there's another one. So which is the other one? Is there's a pi here. So theta is pi plus, and then again, if it is pi, so that means, so if the angle is, if this is pi, okay, then you can do one more 2 pi. So this is pi, so that's pi. So you go all around another one, this become 3 pi. Then again you go on adding 2 pi to this to the pi, you get 5 pi, and likewise we can do the same thing and say, okay, every time it is 2 pi times k, and you're done. So this takes care of this equation. But if you see over here, sine theta is 1. Now sine of what angle is 0? So if you have, and again let me draw the circle like this, sine of 90. So here this is 0, 1, and this is 0, minus 1. It means if the angle is 90 degrees, or which is pi by 2, so this part is sine of 90 is 1, because sine of pi by 2 is 1. So that's why I say, okay, if sine theta is 1, therefore the answer is theta is pi by 2. And then we can also do one more thing, pi by 2, and if this is pi by 2, and you add 2 pi. So it means you are going to add, you go around like this, that will be 5 pi by 2, because it is adding 2 pi. So each of these boxes is pi by 2, pi by 2, pi by 2, pi by 2, and then again pi by 2, 5 pi by 2. Then again we add 9 pi by 2, so multiple of pi by 2. So it is pi by 2, but you are adding 2 pi every time you are adding 1, 2. So basically what I'm trying to say is pi by 2 is the first one, right? The next one is pi by 2 plus 2 pi. The next one is pi by 2 plus 2 pi. This is one of them, or you can say 2 pi times 2. So 4, so 2 rotations, or you can be pi by 2 plus 2 pi, 3 rotations, 3 full rotations. And that's why we say, okay, it is 2 pi, and then k, and that's how you get the answer. But there could be a second question where, hey, we get the answer only from, let's say, 0, and sometimes they ask you to 360, not beyond. So you can't have 360 but 0 to 360. So if this is the answer, then you can say so the theta will be 0, one of the answers will be 0. So if this was the question, where is theta? Then you say, okay, theta is 0, and then theta is this one also, pi by 2, and theta is pi. So the question was asked because this is 0, 90 degrees, and 180 degrees, and you're done. So the question was asked from 0 until 360, but 360 is not included. So then these are the 3 answers, and I hope that completes the problem. Secant theta. So you are given some form there, and you're supposed to find the general. At the most, what can we do is we'll replace tan. Secant by reciprocal is 1 over cosine of theta, and this is sine theta over cosine theta. Then minus cosine theta stays the same, and cotangent by reciprocal identities you can write cosine theta over sine theta equals, this is sine theta. Okay, what else can we do? What are our options? Now this is cosine square and this is sine theta, right? So, we want to have the same common denominator. Let's write one step extra. So 1 times sine is sine theta, and cosine, 2 cosine when you multiply it, cosine square theta. This cosine and this is also cosine square theta, and this one is sine theta is sine theta. What else can we do? Okay, can we get the same denominators? So in order to have the same sine theta here, I'm going to multiply sine theta. Yeah. And in order to have a cosine squared here, let's multiply here. I'm going to write multiply this minus sine here, I write it. And then I multiply cosine square theta, cosine square theta. So both the denominators are the same. So if both the denominators are the same, then the denominator sine theta, cosine square theta equals that sine theta, but this one, this sine and sine times sine is sine square theta. And cosine square is cosine raised to 4, but I'm going to keep it as it is. I'm not going to change it. Let's see why. So this stays the same. And so. Now let's use cross product. So this denominator we can multiply slightly. If we have a over b is c over d, we can use this. So this will be AD equals BC Now, sorry. So I'm gonna use this. This is like A. This part is like A, B, C, D. So you multiply 1 times. So when you multiply 1 times, so you multiply 1. This is you multiply. It stays the same. So that will be sine square theta minus cosine square theta, cosine square theta. And then equal, let me use the black marker. So we multiply this part. Okay, so that will be equal, this sign and this sign will be sine square theta, and there is a cosine square theta. Okay. Okay. What we do next is, let's get a 0 on the right side. So subtract sine square theta, cosine square theta this side, and sine square theta, cosine square theta, so that this crosses out and this sine square stays the same. Now watch out. This is minus sign here. So this is, if you see these two things here, there is a cosine square which is like the same thing. Okay, let me write one more step here. So I'm going to keep this as it is. And then this minus sign. And the right side E is 0. Now watch the fun. We can clearly see that this cosine square and this cosine square, we can take it, use the undo distributive property. So this will be, so I can sine square stay the sine square theta, but this one I can say the green one. So this part, this is that point that what I'm talking about, cosine square. So minus cosine square theta is common. What stays is one of the cosine square theta stays, and this sine squared stays, but plus equals 0. See this? So this minus changes to plus because there's a minus outside. Makes sense? So many steps. And you see by Pythagorean identities, this is nothing but just a 1. So what I left is sine square theta minus cosine square theta is and multiply by 1 equals. So anything multiplies 1 is 1. So this is sine square theta minus cosine square theta equals 0. And this part we can write as I can multiply by minus 1. Let's see why I'm doing this. So if I multiply minus 1, this changes to cosine square theta minus sine square theta equals 0. And then again use the double angle identities that this is nothing but sine of. So this is sine of 2 theta. Sorry. The bell rang, I'm still making the video for you guys, okay? So this is cosine of 2 theta equals 0. Okay, now the question is, when is cosine 0? So if you see remember, cosine is 0 when there is a 90, because this is 0, 1. I like to write again and again, this is pi by 2, see? So this is, so this is the cosine of I by 2. This is cosine, that's sine. So cosine of pi by 2 is 0. Not only that, even here, this is cosine of 3 pi by 2. That means this angle 3 pi by 2 is 0 also. So this cosine 2 theta, you have cosine 2 theta. The answer for 2 theta is, I'm done, is pi by 2 and 3 pi by 2. You just divide by 2 and you get final answer is pi by 4 and 3 pi by 4. And then you can also use your regular answer plus 2. And because this is the period here is 2 pi by 2, which is pi. So you can just write the period times k and do the same thing for the other one. Okay, I think I went too fast here. Let me do this again one more time. So first of all, one thing is good. We know that 2 theta is this pi by 2, and 2 theta is also 3 pi by 2. So that means now I can divide by 2 both sides. So if I divide 2, your theta is pi by 4, that's one of the answer. And then theta here, divide by 2, so you get theta is 3 pi by 4. Okay, now this is one of the answer. Then how do we generalize? So the general equation is theta is not only this pi by 4, but now watch this. What is the period here? So you should know what is the period. So period is always t equals 2 pi divided by the b, where b is this part. That means it is 2 pi over 2, and that is pi. So the period is pi. So that means everything multiple of this pi. So it is pi times k. So this is the general solution where k is integer, and in this case the same thing, it is this 3 pi by 4 and plus again same thing. This time is pi times k. So these are the general solutions. General solution. But it could be, they could ask you, how about getting the answer from 0 to 2 pi? Then you need to be very careful. So it's just pi by 4, and you want to make sure it is not more than 2 pi. So you can write down like this. So the first one is pi by 4, and plus, let's add 1 pi and see what happens. If we add 1 pi, so multiply 4 and 4, multiply, divide, get pi by 4. So still it is smaller than 2 pi. Then if I multiply 2 pi, so instead of 1 pi, let's take 2 pi. And to get this 4, multiply 4, and 2 times 4 is 9. 9 plus 1 is 11 pi by 4. Now if you see 11 pi by 4 here, this 11, 4 times 2 is 8. This 11 is more than, this is greater than 2 pi. So your answer has to be less than pi. So this will not have. So if the question is asked only from 0 to 2 pi, then there's another one here. That's what I'm trying to say. And the same thing will do here. So this is 3 pi by 4 plus pi. How much is that? Multiply 4 again. So this will be 4 pi plus 3 pi is 7 pi by 4. But remember, if you do one more, 3 pi by 4 plus 2 pi and multiply 4, multiply, divide, that's 8, 9, 10, 11 pi by 4. So this one is this 8, this 11 when you divide by 4 will be almost like 3 point something, 8, I don't know, but it is more than 2 pi. So this will not help. So this is the correct. So your answers are, if the question is asked from 0 to 2 pi, your answers are pi by 4, 3 pi by 4, then it is 5 pi by 4, and 11 pi by 4. Hope that helps. So I will continue with this. This problem is problem number 4 and 5. So we'll do 6 and 7 in the class. So today you can complete these two problems. Thank you.